Margaret here at our institute. Margaret is a senior scientist at the SETI Institute, which is just about 2 miles down the road or so, something like that, and is an expert on policy and planetary protection. And her talk is going to be on balancing exploration and use of outer space and lunar environments, addressing the need for practical guidelines. Margaret.
Thank you, Greg. Okay, so this is a heads up. I'm actually a biologist and have gotten into astrobiology and space explorations from the environmental impact statement side of things. The heads up that I have for you is it's even if, no matter what kind of research you do, I suspect that I'm going to touch on something that might make you stop and think about the impacts on your work in the long term. Also, it's not just human missions. This would also apply to robotic questions as well. So this is the talk that is based on a paper that Pascal Ehrenfreund and I have just completed. It will be out in New Space magazine shortly. Okay, how do we do this one? Okay, so all the time we've been looking around at solar system exploration, whether to the moon or elsewhere. We scientists have been looking at things on our own. We have been doing our work, very responsible exploration for 5 decades, but it's been kind of like a dual highway of sorts, and it's now starting to get crowded. The dual highway part is that when you look at how the Outer Space Treaty has been implemented, it turns out that low Earth orbit, geostationary orbit has been one set of policies, and the moon and other bodies has been another. So now, as we've got many new stakeholders and activities getting involved, we need to start thinking about what kind of policy changes will be needed. Think sort of environmental management, environmental stewardship as we go forward. And so what we did is looked at the management of international spaces, and it turns out that we have several of them. We tried to look at what are the practical guidelines that have been used for outer space, Antarctica, and law of the sea. Those are the only international spaces that we have, the only place where we've had experience with that. And thinking especially about the lunar experience, we can identify some gaps that we're going to have to deal with sooner rather than later. So the scientists among us all have this view of activities in outer space, and we're really focused on exploration and new understanding, and that's really the be-all, end-all for our work. In my case, I also think about Mars. I go beyond the moon and think about search for evidence of extraterrestrial life, and I'll use any kind of methods, but especially going there and using robots and other devices to look at rocks and get underneath the surface and try to see things from orbit. All the time when we've been going, we've had 50 years of responsible exploration in every place we've gone, to every body. And it's all been guided by the Outer Space Treaty, which has been ratified and in use since 1967. But if you look at the Outer Space Treaty, we've had that 50 years of guidance and regulations, but there's been a dual implementation of sorts. If you look at low Earth orbit and geostationary orbit, there are multiple stakeholders. There are many, many different legal issues, and that contrasts with moon and celestial bodies. First, if you look at low Earth orbit, when most people think of outer space, there are issues of liability if your spacecraft hits mine or you mess up my satellite. Harmful interference of any sort. We don't go up and mess anybody else's satellite or interfere with space experiments. There's an ownership of assets. When something is launched, the launching nation or group owns it. We have treaties and agreements for the rescue and mutual aid for astronauts. We have international regulations and organizations that deal with communications frequencies, likewise for access to orbital assets. We have satellites that are used all the time. We have remote sensing, and no one would want to interfere with those. We recently have issues of space debris, and we're starting to ask now what the responsibility of launching nations and launching companies should be for the debris that's up there. And now even the FAA has gotten into launch licenses. So you can see that the legal issues and implementation in low Earth orbit and geostationary orbit, what most people would call outer space, is really quite complex. And you'll also note that there's no planetary protection as a part of it. Contrast that to the moon and celestial bodies. That's where we all play. We're like the scientists and governments and the technologists are the ones out there. We're like kids in a sandbox. We all say play nice together, and we base it on one rule. The rule in Article 9 of the Outer Space Treaty that deals with planetary protection. And all of the missions going to appropriate places out there are covered by making sure that we adhere to planetary protection constraints based on the location we're going to. Things are changing fast. New governments are getting involved, commercial groups, private organizations, and partnerships of various sorts. We're focusing beyond low Earth orbit and geostationary orbit, and we have everything from delivering things with a Lunex, which is sort of a Federal X. We'll take your scientific instrument and place it on the moon or someplace. We've got people who are talking about asteroid mining or taking cargo and crew to the moon or to Mars. We've got the idea of space hotels. We've got the idea of Dennis Tito's round-trip mission with a couple going 500 days for a flyby of Mars, or Bas Lansdorp and the Mars One group in Holland, which is talking about human settlements on Mars with people launching up as early as 2023 and landing every 2 years, another 4 people landing. We have the Google Lunar X Prize, which is $20 million for the first private spacecraft that can land on the moon, roll for 500 meters and send back a signal, plus a $5 million prize if you go to a human heritage site. And we have questions about debris removal, waste handling. Some have written op-eds on using 3D items or claims and homesteading. If I get there first, I get to use it. We're certainly interested in building bases or settlements. And I don't know if any of you saw it last week, but there was actually a bill introduced in Congress by 2 Democrats saying we want to have U.S. National Park on the Apollo sites. So things are getting very complicated. The situation as we look at beyond Earth orbit now, we're at a crossroads with many new stakeholders and diverse activities. And we have to ask the question, how do we balance exploration and uses of space? Our emphasis as scientists has been on biological contamination or nothing. We already know there's no life on the moon, so when you guys go to the moon, we don't have to worry about planetary protection. We do worry about the science and want to do good science and think about contamination. And we always update our rules and regulations based on science findings in order to protect the science during exploration. The question is, how does that science contribute to new policy formation? And if we look at where we are, the Outer Space Treaty and planetary protection regulations are mute on the idea of resource utilization and environmental management. There is no code of conduct or any kind of things like environmental impact statements or environmental review process. We are talking about international areas. Every one of these bodies in outer space has no sovereignty, no planting of flags, no ownership, and there's no oversight or enforcement. Oop, how do I go back one?
See the arrows right there.
Okay,
Let's
good.
see.
So that's it. Okay.
Oh, that's...
So in 2010, there was a report looking at ethical issues in outer space. It was the Princeton report. And basically it said, keep planetary protection the way it is, but we have to start thinking about the future directions of other things given the changing political, technical, commercial, and legal aspects of outer space exploration. We need to set the stage now for future work. And so this past December at George Washington University, there was a project, a workshop that looked at what do we want to do to make sure that as we go forward, we develop an environmental regime for celestial bodies that's appropriate for not only just the scientists, but other stakeholders, because the Outer Space Treaty is for exploration and use. We need to have clear definitions. What does it mean to have harmful contamination? What is reasonable use or practical use? What timelines are we talking about? What does environmental stewardship mean of the moon, which is a dead body? How do you establish a database of who's doing what and where? And so we chose to go back to the Outer Space Treaty, all right, you want to do that?
Let's see, where are you?
Okay. We didn't want to reinvent the wheel. We said, let's go back and compare the legal regimes for international spaces. This is a paper that's coming out. We looked at the Antarctic Treaty, which is often talked about, and that's really a science preserve. It's not a UN treaty. It's managed and overseen by countries that have scientific activities, and the only non-scientific use there is the tourism, but that's really minimal use, minimal impact. Outer Space Treaty is exploration and use, and we need to start thinking about attention to the mixed uses beyond Earth orbit and recognize that there are a lot of gaps out there. And the other more complicated international area is the UN Convention on the Law of the Sea. There's multiple uses and zones, so you have some areas being managed by territories, some things that are exclusive economic zones, others that are the open ocean, and we have the international groups and organizations who actually manage them. So the groups that are dealing with fisheries are different than the groups that are dealing with oil and gas and cruise ships and things like that. So there's multiple different groups that deal with it. We don't have the equivalent of that in either Antarctica or outer space. So what we're trying to do is develop a systematic view of what it would take to go forward with scientists and international space organizations. First, you need to know what's going on. What is the database of celestial environments? We really don't even have that. We know a lot about the moon and its processes, for instance, but can we manage it like we manage landscapes here on Earth? What kind of disturbances are important? What kind of disruptions are of concern? The NRC studies have indicated things like dusts and rocket exhaust and various other activities. How much damage could be done before our science is impacted severely? What kind of other activities could be a problem? Certainly when someone goes there for pilot projects, it may not be a difficult thing to deal with, but when they scale up things like mining or tourism, or if there are cumulative or indirect impacts, as we think about on Earth, what does that mean? And what is the time frame for these impacts? Are we going to have the moon be a scientific preserve for the next 50 years, 100 years? Are there ways to mitigate damage or avoid it completely? And how do we get involved with all the stakeholders so everyone sits together and talks these things through? What we're at right now is looking to develop policies for responsible space exploration and use. We have to address the issues in broad and balanced ways, and we have to go beyond incremental efforts. So we had great efforts at the Google Lunar X Prize guidelines, but those were just guidelines. We recently had this proposal for national parks on the moon, but again, do we want to keep taking everything piecemeal or have some sort of roadmap? What science criteria would go into effect for different bodies? We think about preservation as involving life, non-life, and environments or ecosystems. What's the ecosystem on the moon? There is no biology. We don't go ahead and damage the environment like Antarctica or the Grand Canyon. We don't put graffiti on it. So we're preserving non-life. Well, what are the things that we do for here on Earth for life, non-life, and environments? And how do they apply to different places like the moon with no life, or a place like Mars that might have life, or asteroids that we want to mine? So you have to take a proactive approach, and I'd like to see that the scientific community is really a leader in all of this, because if we can't define what the criteria are, someone else will do it for us. And we have to acknowledge that the space sciences will share the resources with others. That's the law. Outer Space Treaty exists to be shared for the benefit of humankind, and scientists have a way of having their resources respected, but we fall into the category of other. We're sort of like historical artifacts or aesthetic or recreational or science. We don't have a category that is as big as, say, biology or physical landscapes as the environment. So as we look ahead, it may seem premature to some of you, but I'd say the objects, it's like our rearview mirror. Things are coming up closer, they appear closer than they appear, and we can't put our heads in the sand and hope it will go away. If the scientific community doesn't get out and start to think about these issues, even when they are uncomfortable, thinking about what does it mean if we don't have a biogeochemical ecosystem? Does that require preservation at the same level as other places here on Earth? And what if we find life on Mars? So there's a lot of wild cards and ambiguity, and There's lots of places where scientists can use their science incrementally and with others to start addressing these issues. Thanks.
Thanks very much, Margaret. Very enjoyable. Yeah. Your last point, I think, was really important about the scientific community defining these things themselves before someone else does it for them. And it reminded me of a historical analog where Stan Cohen and the other inventors of recombinant DNA did exactly that in the 1970s. They realized that there were ethical implications, and they got together before they were told things that wouldn't necessarily make sense.
Yeah.
So,
except they got together in a way that said, let's do a moratorium, and they said, let's keep it in the lab. And so that's actually how I got into all of this, because the first time they said, let's put it outdoors, University of California was involved in the first deliberate outdoor release of a genetically engineered organism, and people said, what law applies?
Yeah.
What guidelines should come into play? And so I kind of took it on as an introduced species problem. I worked on mud snails in San Francisco Bay that came in by the emerging technology of railroads, transcontinental railroad, back at the gold rush days. So the questions haven't changed. They're the same whether it's synthetic biology, nanotechnology, astrobiology, or genetic engineering.
Yeah, yeah.
And we got to get into it.
Yeah, that's right. We, the scientific community, need to be involved. So thank you very much.
Sure.
Wonderful. We don't have any online questions. If you do think of some, please put them down. We really encourage people to chat